last time we talked about odd and even functions, I did this, and I gave you guys the graphs, and I asked you guys, okay, which ones are odd, which ones are even, by looking at the symmetry. Does it have symmetry about the y-axis, or does it have symmetry about the x-axis? But there's another way to do it. You can do it algebraically. And it kind of makes sense when you think about it. Because if a function, let's take for example, this function right here. I'm not going to draw the function. I'm just going to axis, and then let's see, that's going to be x, that's going to be y. Now I have a question. If there is symmetry about the y-axis, what's going to happen when I plug in a negative x, like a negative x and a positive x? What should they have in common? They should have the same y value, right? Because it mirrors. Like if it has this y value, then over here it should have that y value also. Same with down here. Like if it has that y value, then it should have that y value right there. Okay, because it mirrors. It's symmetry about the y-axis. And so there's another way you can say this. You can say, well, if I have the f function and I plug in a negative x, I'm going to get the same y value when I plug in an x. This is a y value, right? Yeah. Yeah. So if I plug in negative x, I'm going to get the same y value as when I plug in a positive x. That is symmetry about the y-axis, and it's also known as an even function. This is even. Okay, let's look at a different example. Let's look at a different graph, but I'm not going to actually draw the graph out. We're just going to kind of talk about it hypothetically. If I have x right here and I have a negative x right here, when I plug both of these x's in, we kind of get the same y, but they're opposites. Like if I plug in this x, I would get this y right here. But then if I plug in the opposite of it, I would get this y right here. And so it's flipped. Does that make sense? This would be symmetry about the origin. And algebraically, it would look like this. If I plug in a negative x, then it's going to give me the y value of the other one, but the opposite. So it's going to be negative f of x. This is odd. This is an odd function. Now, how do we figure this out when we're just given the function right here? Well, you just have to plug it in. You plug in the negative x and see what you get. Simplify it and see what happens. So let's do the first one. If I plug a negative x into this one, this is what would happen. I plug a negative x right there. I raise it to the third power. I plug a negative x right there, and then I simplify. Now, if I raise negative 1 to the third power, that would be negative 1 times negative 1 times negative 1, which would be positive or negative? Negative. That would stay negative. And so we have a negative right there and x to the third. Over here, we have a negative x and a negative 6. When I multiply those two together, what do I get? Positive 6. I get a positive 6. Okay, now look at this in comparison with the original function. What do you guys notice?
It's opposite.
It's the exact opposite. Right? Yes, it's the exact opposite. So that means f of x, or f of negative x, equals the opposite of f of x. Right? If I took the opposite of this, then I would change the signs of those, and it'd be the same thing. So if you get the exact opposite, then you know that this is going to be even. This means even. I'm sorry. This means odd. Man, good looking out, guys. Right? Because that's what we wrote down here. Okay. Now, what about this one right here? Wait, did I do something else wrong? I wrote something wrong. Put an X on the 6? Oh, because when I undid it, it went away. Okay. There's the X. All right, so let's do it again over here. So if we plug a negative X right here, what's going to happen? Now, you get kind of good at this, and you see it. If you have an even exponent, what's going to happen to that negative sign? It's going to go away. We have negative 1 raised to the 4th power. That's 4 negative 1s multiplying to each other. That means it's going to be positive. So we have a positive x to the 4th, and then over here, this is going to be a positive x squared, right? Because negative x times negative x, that would be a positive x. So we have negative 2x squared. We get the same exact thing. That means that when you plug in f of negative x, you still get f of x. So this is even. Now, which one of these has symmetry about the y-axis? The even or the odd?
Even.
The even has symmetry about the y-axis. And then the odd has symmetry about the origin. And when we look at this, our graphs, you can see that. This is the graph of this one. And this one right here is the graph of this one. Look, you see how like the y values are the same on both sides of the y-axis? And over here, the y values are the opposites. That's symmetry about the origin. Okay, let's do the last one. For the last one, we plug in negative x. This is h of negative x. I get negative x raised to the second power plus 2 times negative x. And this is plus 1. Negative x raised to the second power would be a positive x squared. And then I get a negative 2x and then a plus 1. Okay, is this exactly the opposite of what we started with? No. Is it the same? No. So is this even or odd? No, this is neither. You say neither, I say neither. Alright, and then actually when we look at the graph too, you can see that this does have symmetry about the axis of symmetry, which we can find, but it does not have symmetry about the y-axis or the origin. So therefore, it's not either odd or even.